Level 0, 1 atmosphere. That's what's sitting on your shoulders right now, and you've never felt it once in your life. It's such a small, forgettable number that most people go their entire lives without ever learning it exists. The exact weight your lungs, ears, and blood have quietly calibrated to since before you were born. Every breath you've ever taken assumes this number and nothing else. Surfers paddle past the break without a second thought. Swimmers float on their backs and watch clouds go by, completely unaware that the ocean is already negotiating a different deal the moment they dip below the surface. Step off a boat and sink to your ankles, and that number is already shifting beneath you, so gradually you won't notice for a while. It never resets back to one again. Every meter down adds more, and none of it ever gets returned. Pressure in water climbs far faster than pressure in air, because water is roughly 800 times denser than the atmosphere above it. That's the part almost nobody instinctively understands standing on a beach. Climbing a mountain for hours barely changes the number on your body. Descending the same distance into the ocean changes it dramatically in a matter of seconds. A commercial airline cruises at an altitude where the air pressure has dropped to a fraction of what it is at sea level, and it takes an entire flight to get there. The ocean can do the equivalent to your body before you've finished exhaling. This single number, so easy to ignore at the surface, is the one variable that decides everything about what can survive below it, and how strange that survival has to become. Every zone from here down is defined by exactly one thing: how much of this invisible weight has stacked up overhead, and nothing else about the ocean matters more to what can exist there. Go just a few meters further, and your body starts paying for it in ways most swimmers never realize. Level 1. A parrotfish grazing coral at 15 meters is already carrying close to 2.5 atmospheres without any trouble at all. Fish don't fight pressure the way humans do, because their bodies have no large air pockets to get squeezed. Divers aren't so fortunate. At 10 meters, pressure doubles to 2 atmospheres, and the air spaces in your sinuses, ears, and lungs compress right along with it. That's the actual reason divers equalize their ears constantly, and why holding your breath on the way up can tear lung tissue as trapped gas expands on the way to the surface. Recreational divers are trained for years to respect this zone, because most diving injuries happen not at extreme depth, but in these first casual meters where the pressure change per meter is steepest and easiest to underestimate. Free divers push this zone to its absolute edge without any equipment at all, some descending past 60 meters on a single breath. Their heart rate slowing dramatically to conserve oxygen in a reflex the body shares with seals and whales, known as the mammalian dive reflex. This zone also holds nearly all of the ocean's photosynthetic life, the plankton and algae that produce a significant share of the planet's oxygen, meaning the very air you're breathing right now was likely manufactured in this thin, sunlit layer of water. Cross 200 meters and pressure has climbed to 21 atmospheres, while daylight thins into a colorless, directionless blue that barely counts as light anymore. Red wavelengths vanish first, absorbed within the first 10 meters, which is why blood looks black underwater long before the light disappears completely. Somewhere below this exact line, something had already stopped waiting for the sun, and it had to make its own light instead. Level 2. A lanternfish flashes its underside on, off, in a pattern precise enough to look scripted. Down here, sunlight has faded into something too weak to grow a single plant, so evolution answered by creating its own light instead. Bioluminescence isn't a rare trick at this depth. It's closer to standard equipment, and by some estimates, the majority of animals living in this zone can produce their own light in some form. Anglerfish dangle a glowing lure inches from their teeth. Certain squid flood their entire bodies with light to startle a predator mid-strike. Some species use light defensively rather than offensively, projecting a glow downward to erase their own silhouette against the faint blue still filtering from above. A trick called counter-illumination that makes them nearly invisible from below. By the time you reach 1,000 meters, pressure has hit 101 atmospheres, beyond the operating depth of most conventional submarines. And every night, without exception, an enormous mass of this zone's fish and plankton rises hundreds of meters to feed near the surface, then sinks back before sunrise, known as the Diel vertical migration, the largest migration of animal life on the planet, repeating on a schedule nobody down here can see, so vast in scale that ship sonar operators once mistook it for a false seafloor, a phenomenon that puzzled the Navy for years before biologists identified what was actually causing it. Some fish in this zone have eyes that point permanently upward rather than forward, scanning for the faint silhouette of prey against what little light remains above them, an adaptation found almost nowhere else in the animal kingdom. Others have given up eyesight as a primary sense entirely, relying instead on long, whisker-like fins that can detect the faint pressure wave of a smaller fish swimming nearby in complete darkness. But even these glowing residents have a ceiling. Past a certain depth, eyes stop offering any advantage at all. Level 3. Submersibles rated for this zone are built with hulls thick enough to resist being squeezed from every direction simultaneously, because that's actually how pressure behaves down here. It doesn't drop on you like a weight from above. It presses in evenly from all sides at once, which is why a body underwater doesn't get crushed flat the way most people picture it. The real danger is the air still inside you. Lungs, sinuses, ear canals, those are the parts that fail first, collapsing under a pressure gradient the rest of your tissue barely notices. Another 300 atmospheres accumulate by 4,000 meters, where you're carrying 401 atmospheres total, distributed evenly across every square inch of your body. Sunlight never makes it this far, absorbed completely by the water above long before it could reach here. Temperatures here hover just above freezing, year-round, with almost no seasonal change at all. One of the most stable environments anywhere on the planet, arguably more stable than anywhere on land has ever been across recorded history. Sperm whales dive straight into this blackness anyway, holding their breath for over an hour, hunting giant squid by sound alone, in a place with zero visual reference points to navigate by, using echolocation clicks powerful enough to be heard by other whales kilometers away. Some fish at this depth have lost their eyes almost entirely, relying instead on pressure-sensitive organs along their bodies that detect the faintest ripple of movement from something approaching in total darkness. Food is so scarce down here that many species have evolved jaws that unhinge far wider than their own bodies, built to swallow anything they encounter because a second meal might not come for months. Go deeper still, past where whales are willing to follow, and sunlight stops being the only thing that never arrives. Level 4. Cracks in the seafloor here vent water hot enough to melt lead, chemically toxic and completely lightless. Around those vents, chemistry became the foundation of an ecosystem unlike anything on the surface. Tube worms cluster by the thousands near these hydrothermal vents, feeding off bacteria that convert poisonous compounds into usable energy through a process called chemosynthesis, running a food chain that never once touches sunlight, from the bottom of it to the top. Some of these vent communities were only discovered in 1977 near the Galapagos Islands, and they overturned a scientific assumption that had stood for over a century, that all life on Earth ultimately depends on the sun. The water gushing from these vents can reach temperatures over 300 degrees Celsius, yet it doesn't boil because the immense pressure at this depth raises the boiling point far beyond what it would be at the surface. Cross into 601 atmospheres near the base of this zone, and the pressure is roughly equivalent to 60 small cars worth of weight, spread across your body from every direction at once. Most surface animals dropped here unprotected wouldn't be flattened. They'd fail from the inside as every air pocket in their bodies collapsed under a gradient they were never built to equalize. This featureless, lightless plane covers more of Earth's surface than every continent combined. And NASA itself has noted that there are better maps of the moon's surface than of the bottom of our own ocean. Most of what lives out here has never been photographed alive, only recovered in trawl nets or glimpsed briefly by a passing camera sled. But even this isn't the floor. The ocean has one more layer left, narrower, deeper, and far more hostile than anything above it. Level 5, named for the underworld, and it earns the name honestly. This zone only exists inside narrow trenches where one tectonic plate slides beneath another, carving canyons deeper than any mountain on land that stands tall. If Mount Everest were dropped into the deepest of these trenches, its summit would still sit over 2 kilometers underwater. The Mariana Trench holds the deepest of them, Challenger Deep, at roughly 10,935 meters. Here, pressure passes 1,100 atmospheres over 8 tons of force on every square inch, equalized from every direction the same way it is everywhere else in the ocean, just scaled up to a number most minds struggle to actually hold on to. A styrofoam cup lowered to this depth returns as a tiny version of itself. Every microscopic air pocket inside the foam gets compressed by the enormous pressure, leaving the same cup, only a fraction of its original size. Fewer people have reached that exact point than have walked on the moon. Each descent takes hours inside a titanium sphere engineered specifically to resist a gradient that would otherwise crush it in seconds. When researchers finally pulled sediment samples up from that seafloor, they found amphipods living in it, small shrimp-like creatures that hadn't just endured the crushing conditions, they'd built their entire biology to depend on them. Their cell membranes and proteins are structurally different from their shallow water relatives, engineered by evolution specifically to remain flexible under pressure that would seize up ordinary tissue like concrete. Plastic waste has even been found in sediment samples from this exact trench, a reminder that nowhere on the planet, no matter how remote or crushing, has stayed fully out of reach of the surface world. Every trench on Earth remains only partially explored, and each new dive tends to bring back a species nobody had documented before, sometimes several in a single trip. And every expedition that reaches this deep finds something new down there, something that shouldn't, by any earlier estimate, still be alive.